Hi, in this video we are going to talk about templates in C++. The idea is to write code once and use it for any data type. So what we do in templates, we provide a sample code, a generic code, and compiler automatically generates data type specific code whenever you need this code for a particular data type. That's the idea of templates. So like macros, templates are processed by the compiler, and compiler, whenever you need a template for a particular data type, your compiler generates code for you. It mainly avoids you typing all the code for every data type and let compiler doing the job. There are two types of templates, function template and class template. We'll cover these two templates in two separate videos. So the idea is this: function template means for functions like sort, linear search, binary search, you can just provide a template, and then whenever you need this sort function for any data type like int, char, long, you can just pass the data type as an argument to the compiler, and compiler will generate the code on fly for you, and this code will then be called for that particular data type. So binary search is a standard algorithm, and you would like to have binary search for characters, floats, integers, and all those data types. Maybe your user-defined data types. You have an array of students and you want to do a binary search for a roll number, right? So you can use the same function. Class templates. Class templates are similar to function templates. Here we use templates to reproduce the code for different data types. You might want to have a stack of integers, stack of long, stack of double, stack of student data type, or any other data type. What do? You make a generic class which can take data type as an argument at compile time, and that's the idea of the templates. And then when you pass a particular data type, it generates the code on the fly whenever you need code for any data type. Last point is, templates is the main idea behind STL, the most popular library in C++. So STL, the standard template library, its name contains template. It has all the popular functions and classes built as a template, right? So they can be used for any particular data type. You can pass the data type as an argument, and you can use the same function for all the data types. Let us now discuss an example code of templates. Let us take a look at this code. We have a function template. So this template is a keyword in C++. Type name is also a keyword which is used for this purpose. However, type name can always be replaced by the keyword class also. So you can either use a class keyword or type name keyword here. Then we have a template function which takes data type t as a parameter. So this is just the data type parameter which is processed at the compile time. You can give it any name like LMN or anything. I've just written t here because most of the textbooks and everywhere we use t. And the return type is t. The two parameters have t type. We just do comparison of both the parameters and return the maximum of these two. Now we are using this myMax template, the template that we have created here. This is the function template that we have created. We are using it for finding the maximum of two integers. So this call, what happens in this call? This int parameter is passed as a parameter to this template, and then a function is created which has int in place of t everywhere, and then this function is called, right? So your compiler creates a function where you have int everywhere in place of t. Now when you call for char, one more function is created by the compiler which has char in place of t everywhere, and then this function is called. So the idea is you are providing only a template and compiler is doing the code writing work for you when the template for multiple functions is same, right? That's the idea. So what we get? We get as an output 7. This all happens behind the scene. We do not have to worry about it. We get the other output as maximum of C and G, which is G. So that's how templates work internally. Compiler internally creates two functions, one with int in place of t and one with char in place of t. And if you make one more function call for float or your own defined type, then one more function will be created, right? If you are using the same template for your own class, you will have to make sure that your class does operator overloading and overloads this particular greater operator, right? Then only you can use it. That is something you have to make sure in your class. Let us now talk about differences between macros and templates. So this is an example template that we just talked about. I've renamed it as mymax1, and this is an example macro where we pass two parameters x and y, and it simply replaces this expression everywhere in your main with this expression, right? So how macros work internally? There's a pre-processing phase in the compiler, and what this preprocessor does, whenever it sees a macro defined like this, it replaces this expression with this expression in the whole main program or wherever you use this macro, anywhere in all the functions defined in this file where this macro is defined. Now the problems with this macro approach is it does not do type checking. It simply does search and replace, right? Type checking cannot happen at all because it's happening in the pre-processing phase, right? The first thing that happens in the compiler. The second problem is it's error prone. There are many possibilities of errors when you use macros because it's simply search and replace. Third problem is difficult to debug. If you are using a macro and your preprocessor has searched and replaced the expression with the macro, then you will be getting the errors in the expanded form, in the replaced code, right? Which are difficult to debug. Also, type checking happens here in templates. You get better errors, you get type checking, and it's less error prone because it's simply a function call, not blindly search and replace. So templates are much better than macros whenever we have some code that we want to reuse for different data types. In this video, we introduced templates, which is a great idea to avoid rewriting the same code for different data types. We let the compiler do the work for us. In the upcoming videos, we'll talk about function templates and class templates.